So hello everyone, welcome to this new lecture. So in this lecture, wait, do you remember how to solve any equation? Any quadratic equation? Come here. Do you remember this equation that you solved in class 10? Tell me this one. Find the value of x. How will you find the value of x in this equation? X square minus 1 equal to 0. How you are going to find the solution of x? What is the value of x? This x, not. Okay. So come here. So how are you going to find this one? X, we are going to shift this minus 1 to the right hand side. So x square equal to 1 implies x is equal to plus minus root over 1. We know square root of 1 is 1. The value of square root of 1 is 1. And plus and minus always come in front of the square root. You remember this one? Yes? So the value of this one is either x equal to 1 or x equal to minus 1. Okay. But what we will do here? Simply we are going to take this plus 1 to that side, it will become minus 1. Then we are going to do square root in both the sides. Let's do it. X square equal to minus 1 implies x is equal to plus minus root over minus 1. Okay. We know square root of 1, that is 1. Square root of 4, 2. We know square root of every positive things. Sorry, not only positive, we know square root of every non-negative element, every non-negative number. Non-negative number. Okay, keep in mind, non-negative number. We know square root of every non-negative number. But what about this negative number? Not only this one, let's say any negative number of this world. What about the square root of any negative number of this world? How are we going to solve this one? Can you find? Can you? Acha. If not, wait. In class 10, do you remember class 10 solving the quadratic equations? Come here. In class 10, the most famous quadratic equation or general quadratic equation is this one. Ax square plus bx plus c equal to 0. This is a general quadratic equation. General quadratic equation. We have many ways of solving this one. Elimination way and, sorry, these are for linear equation, not quadratic equation. But still, there are many ways for solving quadratic equation. Middle term, then factorization and so on. But there is a special formula for solving any quadratic equation of this world. Any quadratic equation, any. Okay, what is that? That is Sridhar Acharya's formula. What is that one? Go to class 10 book and see that one. Okay, but come here. Ax square plus bx plus c. This is a general quadratic equation. So if I ask what is the value of x or find the value of x, how you are going to do this one? Simply x is equal to minus b plus minus root over b square minus 4ac divided by 2a. See this one. X equal to minus b plus minus root over b square minus 4ac divided by 2a. So this is the general form, or you can say in this method you can find the roots of any quadratic equation of this world. Yes, of this world, any quadratic equation. Understood? And you know this one. And this formula is given by Sridhar Acharya. You know that one? Yes. So this is the formula. Wait, you might be thinking I have given a heading like complex number. But why I am telling this one? This is of class 10. Wait. Just a bit. Just a little moment, okay? Just wait for 1 minute. I am going to tell how this complex number came in this world. Complex number is one of the biggest branch of mathematics. So how this arises in this world? So I am going to say that one. But we know this one is the what? Root of x. In that, this part, b square minus 4ac. This b square minus 4ac, we call this one as d. Okay, we just name this one. We are just naming this one. B square minus 4ac as d. What we will do that with this one? Is there a special use for this one? Yes, there is a very special use for this one. What? Come. This b square minus 4ac is equal to d. But here, 3 cases arise. Either d greater than 0, d equal to 0, or d less than 0. In class 10 you have already read about d greater than 0, d equal to 0. What happens when d is greater than 0? When d is greater than 0, we are getting two distinct real root. Two distinct real root. Two distinct. Two distinct real root. But when d is equal to 0, we are getting not distinct, but yes. When d is equal to 0, we are getting equal roots. How? Don't worry, how we are getting, I am going to show you with an example. But first see this one. Okay? When d is equal to 0, we are getting this one. Is this one visible? See this one. We are getting the equal roots. Okay. Now, when d is less than 0, what about when d is less than 0? What we will do when d is less than 0? So, in this case, yes, the complex number came from this concept. We have only learned about d less than d greater than 0 and d equal to 0 in class 10. But we don't know about we don't know what will it happen when d is less than 0. See this one. And we in classes we have learned this one as something imaginary one, something imaginary type. In class 10, our class 10 teacher has told us just this is something imaginary case. Okay, we will read it in further classes. But now you are in that class where when you are going to read this one, and you are thinking just this one may be a very small topic. No, this one is the biggest topic of mathematics. This one is the biggest topic. Understood? So, imaginary case. But you will be thinking, what I am saying this one, imaginary case, why I am writing here complex number? You want to know why? Just a second. You've done this one? Okay. Now, to solve this type of problem when we are getting something negative number inside the square root, when we are getting any negative number inside the square root, what can we do? When we are getting a negative number inside the square root, we are assuming something. Assuming means we are considering this negative root over minus 1 as something. What something? We are considering this one as iota. What? Come. See. We are considering root over minus 1 as iota. Yes. Yes, this is iota. And how does the symbol of iota represent? Simply, we can write this one by a small I. We can represent this iota by a small I. That means, the answer to this problem is x is equal to plus minus iota. And so this one, is this one visible or what? Yes, this one is visible. So, we are going to represent this one as iota. And so, you might be thinking what we will do by using this iota and all. Okay, see this one. So, what we will do is, let's check this problem. In question they have given like, find the value of how can you find this one? We know square root of 625 is 25. We know this one. But what about this minus? Huh? What about this minus? Yes, we are going to take the help of this iota. How? How we are going to take the help of iota? Do you want to see? Come. Minus 1 into 625. Okay. Understood? Now, minus 1 into root over 625. We know square root of this one is 25 and this one is iota. That means 25 iota. This is the answer. Are you getting my point? Yes. Now if you go and check your book, you are going to find many such problems. Okay. I am first showing you some another type of problem, that is, let's say this one. We know, see this one, note down this one, this is the most important part of the first exercise, okay? Values, okay? I is equal to root over minus 1, okay? I square is equal to minus 1, okay? I cube is equal to minus I, okay? And I to the power 4 is equal to 1. Note down this one. Note down this 4, okay? You must note down this 4 and you must recall them. Okay? You must recall them. Now, you might be thinking how this one came. Are you thinking this one? Okay, see this one. We know I is equal to root over minus 1. When I square means squaring both sides. So, I square equal to root over minus 1 whole square, that is minus 1. When this way minus 1 came. I cube, okay. I cube, that is, we can write I cube as I square into I. Are you getting my point? I cube equal to that is I square into I. What is I square? I square is minus 1. Minus 1 into I, that is minus I. Sorry, minus I. Are you getting my point? Is this one visible? Yes, this one visible. And if you are facing problem, you can zoom the screen. Okay, if you try to zoom the screen, if you cannot see, this one properly, you can zoom the screen. Okay. Now, what if I to the power 4? See, I to the power 4. It is I square into I square. What is I square? Minus 1. What is I square? Minus 1. Minus 1 into minus 1. It is 1. It is simply 1. And you know minus into minus is positive. So simply 1. So in this way you can easily solve the first exercise of complex number. From any book. From any book you can solve. Really? Wait, let me show you some special type of problems. But we just do something. You just keep this one in mind, okay? Root over 4 into root over 9. That is 2 into 3. That is simply 6. But root over minus 4 into root over minus 9 is not equal to 6. We just keep this one in mind. Root over 4 into root over 9 is 6. But root over minus 4 into root over minus 9 is not equal to 6. Minus 6? No. Then what can we write as 4? We can write 4 as root 4 into I. How? Like simply we just shift the minus 1. You just shift the minus 1 to another square root. Okay? Then you will be easily getting this I. Next. And what is the value of I square? Minus 1. That means minus 6. Therefore, this one and this one is not equal. Understood? Are you getting my point? Yes? Okay. Next one. In book you may see some problems like that. I to the power 63 or I to the power 279. Such big problem. How are you going to solve this one? Listen to me. If you know what is the value of I square, I cube, I to the power 4, then you can solve this one, any type of problem. Understood? How? See this one. Let's try with this one. So what you will do, you just divide the power by 4. Okay? 63. If you divide this one by 4, 1. Then 3. 3 is the remainder. Now, we know a formula. Dividend is equal to divisor into quotient plus remainder. That childhood formula. Can you recall? Yes, that one only. So we are writing this one as 4 into, what it came? I guess 15 it came, yes. 4 into 15 plus 3. Why have we written this one? Like this, multiply. I to the power 4 into I cube. Why have we written this one? We know the value of I to the power 4 is 1. Can you recall? If you can, then just skip to the first part again and see that part. I to the power 4 is 1. Value of I to the power 4 is 1. So we just simply put this one. 1 to the power 15 into I cube. And 1 to the power anything is only 1 only. And what is the value of I cube? That is minus 1. So simply minus I. Understood? The value of I cube is minus I. So you can simply write, we are simply getting this one as minus I. Understood? Minus I into 1, that is minus I only. Okay? So this one, can you try this one at home? How will you do this one? You divide this one by 4, 279. Then one remainder will come. Then write it only in this format. Then solve this one. Okay? Easy? Okay. Let me show you another problem for the first exercise. Let's say they have given like this. I to the power 2000, let's say 20. I to the power 2020 plus I to the power 2021 plus I to the power 2022 plus I to the power 2020. Is this one visible? Yes, this one is visible. And if you can see, you just zoom the screen. Okay. So how will you solve this one? Are you going to find first for I to the power 2020, then 2021, then 2023, then 2022? Are you going to find in this way? Don't do this one. You will be not getting so much time for doing this one. You will be getting maximum to maximum 2 to 3 minutes for solving this problem. Okay. So how will you do? Just simply take common from each of the terms. How? See. Which one is the smallest one? 2020 is the smallest from all this one. So take I to the power 2020 as common. I to the power 2020. So if you take common, we get I. So 1 plus this one is I. This one is I square. This one is I to the power cube. Okay. Now what is the value? Wait. Write this one. I to the power 2020. Okay. Now 1 plus I. What is I square? Minus 1. What is I cube? Minus I. Now the next step, you see this one. Minus 1, 1. Minus I. Everything got cut. So we are getting 0. I to the power 2020 into 0. That is 0. Simple. Simple. Okay. So that's all for the first exercise of complex number. Okay. So in the next chapter or in the next lecture, we are going to show you some special problem. Also, how this complex number arises. So we are going to take like this plane in which x-axis will represent the real line and y-axis will represent the imaginary part. Okay. So see you in the next lecture. Okay. Till then, complete the full exercise. Okay. Bye bye.